In last week lecture, we have discussed about the hybridization, each type of hybridization. Okay, we have looked at the type of hybridization for SP, SP2, SP3, SP3D, and SP3D2. So as I've told you earlier, I have made some arrangement to the original slides. Okay, in terms of hybridization part. I have rearranged the slides, okay, into few categories ataupun few groups. Okay, so we have hybridization. So I have divided into 3 categories. Okay, so the first category would be molecule having all single bond. Okay, and then secondly, we have molecule having lone pair. Okay, and then lastly, we have molecule having multiple bond. So the multiple bond can be either double or triple bond. Okay, all right. So saya classify. I have divided the hybridization slides into single bond, lone pair, and multiple bond. Okay, Alhamdulillah, we have covered all of these 3. Okay, so now let's go back to the original slides. Okay, we go through the slides. I mean, very roughly kita go through the slides to make sure that we don't miss out anything. Okay. Alright, so the reason saya divide into these 3 categories so that you know what is the difference between single bond dengan lone pair and also multiple bond. Okay, for single bond, basically, if we could summarize all of this, single bond, basically, we expect that all the orbital has one unpaired electron. Okay, so all orbital should have all hybrid orbital. We are talking about hybridization, okay? All hybrid orbitals should have unpaired electron or single electron. Okay? And then for lone pair, we expect that the hybrid orbital should consist of full field, either a full field ataupun satu full field ataupun it can be more than one. Okay, full field orbital. Okay, so a full field orbital represent the lone pair. Okay, all right. For multiple bond pula, we expect that if we have multiple bond, we refer to we regard to the Lewis structure, and then we identify there's a double bond. That means we have one pi bond there. Okay, right. So if there is a multiple bond, it's either double bond or triple bond. That means we will have ataupun we expect the hybridization will have the unhybridized p orbital. Okay, so if it is double bond, if it is a double bond, that means we will have one unhybridized p orbital. If we have triple bond, that means we will have 2 unhybridized p orbital. Okay, all right. So these are the main characteristic of each category: single bond, lone pairs, and multiple bond. Saya divide into these 3 so that you can see it clearly. Okay, for single bond, we have looked into SP, SP2 until SP3D. Okay, all right. So and then we have lone pair. Lone pair, we have SP2, SP3. Okay, so it depends. You have to decide on. You have to determine the type of hybridization dulu. The type of hybridization depends on the number of electron groups, okay, that present on the central. Okay, all right. So from the Lewis structure, you boleh predict, okay, that the hybrid orbital should consist of the lone pair. If you have one lone pair, that means we should have one fulfilled orbital. The rest are all single bond. So that single bond, that means we have unpaired electron in the hybrid orbital. Okay, all right. So for multiple bond, if from the Lewis structure kita observe, okay, we have double bond between the central. That means you should have one hybridized p, one unhybridized p orbital. Okay, that has one electron in it, unpaired electron in it. So that later the unhybridized p from one atom and the unhybridized p from another atom will combine, or the orbitals will overlap and they will form a pi bond. Okay, alright. Jom kita tengok each one of them. Right, so kita last time for the original slides, okay, the end slide will be this one, and then kita to change to the new arrangement. Okay, alright. So we have carbon hybridization. So carbon can form three types of hybridization. Carbon can form sp3 hybridization, sp2, and also sp hybridization. Okay, alright. So kalau based on the original slides, it start from sp3. Okay, it start from sp3. Kalau the new arrangement slide, the new slide last time, kita start from sp. Okay, for the bonding for all the single bond. Okay, so kalau original kita start from sp3. So this is how sp3 hybrid orbitals looks like. Okay, so we're gonna start from ground state and then excited state and then combine. Okay, the S and P will be hybridized and form an sp3. Nampak tak? All of them are unpaired. Okay, so this unpaired electron will later on form bond with 4 hydrogen. Okay, from the Lewis structure itself, you can predict the orbital diagram that you would get for the hybridization. Okay, and then don't forget that the question can also be asked in terms of orbital overlap. Okay, all right. So orbital overlap, I would say it is easier compared to orbital diagram. Orbital diagram, there's a lot of things that you need to consider. Okay, it need to be promoted and then combined, and then sometimes dia tak promote pun, dia terus je combine. Okay, so you can consider all of that. But for orbital overlap, you can just use your Lewis structure as your reference for you to draw your orbital overlap. This is what we call orbital overlap. Don't get confused with orbital overlap and orbital diagram. Jangan confuse So orbital diagram kita guna kotak-kotak. Orbital overlap is to represent the real orbital. Okay, to draw the orbital overlap, senang saja kita tengok your Lewis structure. Okay, as you can see, we have 4 bonds there, and then this is sp3. We have determined it earlier kan. So this is sp3, 1, 2, 3. We need to determine this first. This should be determined first before we proceed to orbital diagram and orbital overlap. Okay, it is sp3. So next, to draw the orbital overlap, you just count total the number of hybrid orbital. 3 plus 1 is equal to 4. That means you have to prepare 4 loops. 4 cuping. Okay, so 1, 2, 3, 4. And then it combines. This is carbon sp3. Please do not forget to label. And then this is for carbon. Hydrogen. How about hydrogen? Okay, so this is hydrogen. So we have 4 of them. Yes, and then label. Okay, just for your checklist. Okay, just this is for your checklist. Okay, so that you can make sure that you have covered all. Green. Okay, all right. So we have drawn the carbon. Okay, we have drew the carbon here. So this is the hybrid orbital for carbon, and then hydrogen, all the hydrogen have been drawn. Okay, so kita dah ada. Don't forget the electron. So the electron is this bond. Okay, all right. So all the bonding kita dah cover. All the bonding have been covered. Okay, so there you go for your orbital overlap. Simple je. Okay, but normally the question would ask for orbital diagram. Orbital diagram is the most famous question asked in the exam. Okay, but we do have orbital overlap too. Tapi you kena tahu, basically you need to know both of them lah, orbital diagram and orbital overlap, because it's not based on you. Okay, it's not up to you to decide you nak kena orbital diagram ke orbital overlap. It depends on the question. Okay. Alright, so still sp3, but this time around sp3 but with one lone pair. Okay, this is still sp3 tapi ada satu lone pair. Nampak tak dia arrangement slide ni? Dia single bond and then terus ada lone pair. Okay, single bond terus ada lone pair. Kejap lagi single bond and then ada multiple bond pula. Dia terus macam tu. So dia mungkin you can get confused. Okay, sebab you just been introduced to single bond, then suddenly you were introduced to lone pair, and then next you have multiple bonds. Okay, so dia berlaku serentak, jadi takut you confused. That's why saya buat arrangement, new arrangement to the slides. Okay, but regardless kita go through sahajalah. Alright, so for sp3, okay, for NH3 you have to draw. As you can see, you dah nampak dah one lone pair. So you should bear in mind, in the hybrid orbital for the central, you should have one full-filled orbital. Okay, you should have one full-filled orbital because we have one lone pair on the central. Okay, all right, so ground state for nitrogen. So this is the ground state for nitrogen. As you can see, the excited state for nitrogen and the ground state, they are the same. Maksudnya there is no promotion of electron takes place. There's no excitation of electron. There's no excitation of electron. Okay, and then proceed to hybrid. Okay, this time around, the S and P will undergo hybridization and form this hybrid orbital. So as you can see, this will represent the lone pair that we have on the Lewis structure, and this later hydrogen will come in order to form bond. So we have 3 hydrogen there from the Lewis structure, right? Okay, so this is your hybrid orbital. So how do you draw the orbital overlap? Okay, you may use, please refer the Lewis structure. So this is sp3, that means you have to prepare 4 loops. Okay, all right, so we are done with nitrogen. So this is nitrogen. Okay, as you can see, we have 3 hydrogen there. Okay, so for hydrogen, kita represent using red ink. We have 3 of them, hydrogen. Okay, so hydrogen dah settle. Okay, and how about the bond here? Okay, so to represent that on the orbital overlap, we need to represent it using electrons. Let's have blue. Okay, so one should come from hydrogen, the other one should come from nitrogen. Okay, don't forget to label, guys. This is sp3. Okay. And one more. Okay, so these 3 bonds are now covered. Okay, so all of them are sigma. If you are asked to show the formation of sigma on the orbital overlap, so please make sure you label. Okay, and then how about the lone pair here? Okay, we have 2 lone pair there, so that means you have to have lone pair here. So all the lobes should be fully occupied with electron. Okay, dia tidak ada lobes yang available, yang empty. There should be no empty lobes ataupun empty hybrid orbital. Okay, mesti ada electron in it. Alright, so this is our NH3. orbital overlap. Right? Okay. Yep, that one. Okay. Then kita ada sp2. So just now we have sp3. Next we have sp2. Okay. So sp2 having all single bond. Example of sp2 is BH3, boron trihydride. Okay. All right. So this is boron ground state, and then this is the excited state, and then it will form sp2. Okay. It will form sp2. That's why you have sp2 here. Okay. You have determined this earlier because it has 3 electron group on the central. Okay, all right. So this is your orbital overlap. You should have 3 lobes, and then you should have apa nama tu, hydrogen using circle. Okay, to represent the orbital of hydrogen, orbital S, and then don't forget the region that they both overlap. Okay, you should include the electron in it. Okay, all right. So this should be sp2. All right, and then what happens if we have double bond? Still sp2, guys. Okay, so this is still sp2, but this time around sp2 with multiple bond ataupun sp2 with double bond. Okay, example we have C2H4, right? So C2H4, the Lewis structure is this. This is the Lewis structure for C2H4. Okay, all right. So we have C1 and C2. That means we have 2 centrals there. That means you have to have 2 hybridization. You have to have 2 orbital diagram. Okay, because we have 2 centrals. So we have to determine the hybridization for C1 will be sp2. 1, 2, 3. How about C2? It is also sp2. 1, 2, 3. So this is sp2. Okay, all right. So if we have more than 1 central, that means each central should have its own hybridization. Okay, it should have its own hybridization. As you can see from the slide, we only have 1 orbital diagram. Let's just assume this is for C1. By right, you should have 2 orbital diagram. C1 and also C2. Okay, so C2 in this case, for C2H4, okay, the C2, the central number 2, will have exactly the same orbital diagram as C1. That's why mungkin dia tunjuk 1 lah dekat situ. The reason dia tunjuk 1 dekat sini. Okay, so please make sure you add notes ke dekat situ. Kenapa dia tunjuk 1? Supposedly you should have 2 orbital diagram for you to form bond, okay, between the carbon and carbon. This one, especially for this one, this carbon. Sorry, this bond. Okay, so it's between carbon number 1 and carbon number 2. How do you connect them? That means you should have another hybrid orbital lah, which is for C2. Okay, so let's just assume this is C2. We have sp2, and then we have 1 unhybridized P. Okay, it is exactly the same as C1. Okay, all right. Maybe I can draw the Lewis structure down here. Okay, so this is C2. Saya cut short dekat sini, terus je straight forward pergi kepada the hybrid orbitals. Okay, alright. If we were to form a bond with another atom, which is in this case hydrogen, okay, so this one, okay, refer to the Lewis structure just now. So this carbon will form bond with 2 hydrogen, right? So C1, okay, so this is C1, C2. Okay, so this hydrogen will form bond with this electron. Okay, we'll share the electron with the electron from the hybrid orbital of C2. C2H4, sorry, for C1 lah in this case. Okay, all right. And then we have another hydrogen coming in, forming another bond to this one settle. So we have 2 already. Okay, so how about this one? This, okay, kita settlekan for C2 juga. C2 pun sama. Hydrogen will be coming in So we have 2 hydrogen. Settle. Right? So next, how about this bond here? So this is sigma, and the second bond is pi bond. So this will overlap, guys. This is sigma bond. So from sp2, okay, for sp2 from C1, it will overlap with sp2 single bond from a single electron from carbon number 2. Okay, all right. So how about this one? This unhybridized P. This is what we call unhybridized P. So this unhybridized P represent the pi bond. Okay, represent the pi bond. So we have 1 pi bond on the Lewis structure, 1 pi bond between carbon number 1 and carbon number 2. So basically this one will overlap with this. So this is the pi bond. Okay, so this is the pi bond. So you kena ada 2 lah. That means kalau you ada 3 pun, 3 ke 4 ke 5, that means you imagine you should have 5 orbital diagram to represent all the centrals. Okay? Alright, so now how do we draw the orbital overlap? Okay, how do we draw the orbital overlap? So okay, so H. Right, so we have determined this just now. It is sp2. This is also sp2, right? Okay, so sp2, that means we should have 3 lobes there. Okay, trigonal planar shape. 3 lobes, that means 1, 2, 3. Okay, this is for C1 sp2. Saya buat dekat bawah sebab nanti nak draw the unhybridized P there. Right, this is for C2, 1, 2, 3. Okay, alright, so this is C2, sp2. Alright, so we are done with carbon. Carbon dah, okay, tick dekat Lewis structure just now. Okay, next, let's have hydrogen for each carbon. Okay, so we have 1 hydrogen, the second hydrogen for C1, and then we have 1 hydrogen for C2, the second hydrogen for C2. Make sure that you label everything. Okay, all right, so the hydrogen are now drawn in the orbital overlap. Kita dah draw. Next, okay, don't forget the electron, guys. Saya hampir lupa because without the electron, you will not be given mark for that, okay? Okay, don't forget this. Okay, so bond, okay, kita dah tunjuk the electron, that means kita dah covered for the bonds. All the bonds dah covered for the sigma bond, okay? How about the tengah ni, the middle? Okay, this one, covered. That will be sigma. Okay, alright, so now, how do we represent the unhybridized P, the pi bond? So let's use green. Okay, the pi bond, so you have to have the P, unhybridized P. So we know that unhybridized P can be in the form of PX, PY, PZ. It should be one set. Dia ada atas dan bawah. Okay, alright. So this is for C1 and we have C2 as well. Okay, so these two should overlap with one another. But since dia dah extended, dia jadi memanjang ke belakang, jadi dia nampak macam dia tak overlap. Sebenarnya in reality all the bonds, they are overlap with one another. Okay, so limitation 2D ni macam ni lah. Bila extended dia, kita boleh lukis 2D dengan cara overlap. Tapi dia akan jadi serabut lah sebab semua terlampau close to one another. We have troubles in deciding whether is this a sigma bond ataupun pi bond because they are too close. That's why kita extend, kita panjangkan dia. Tapi nampak macam dia tak overlap, tapi sebenarnya dia overlap. Okay, alright. So you connect these two. Okay, this would represent the pi bond. Don't forget the electron, guys. So we have 1 pi bond dekat situ, atas dan bawah. So atas, tengok tangan saya ni, ke atas dan bawah dia overlap sekali. Ni atas, ni bawah. Okay, dia tak boleh atas saja. Dia bukan 2 pi bond, 1 atas, 1 bawah, bukan. Dia one set. they should overlap. Okay, dekat top dengan bottom. That is considered as one pi bond. Okay, alright. So there you have your orbital overlap. Dah siap. Okay. So menggunakan Lewis structure saja. So this would represent the unhybridized p orbital, which will form pi bond later. Right? Okay, so next we have SP, guys. SP, all right. So SP having all single bond, we have BeH2. Okay, all right. So this is if it's single bond, if it only involves single bond. Okay, so we have two unpaired electron in the hybrid orbital. Okay, so this is the ground state. Dia kena promote masuk dekat p orbital and becoming this, and then dia akan hybrid, combine. Okay. Alright, and then we have SP, but having pi bonds. SP having pi bond. Okay, alright. Example, this time around we have C2H2. Okay, sama juga. So this is the Lewis structure for C2H2. As you can see, we have triple bond between the two carbon. That means by right you should have C1 and then another the same orbital diagram for C2. Okay, katalah C2 here. We have C2. Okay, so this is the hybrid orbital for C2. Right. Kalau ada dua unpaired electron in the unhybridized P, that means it will form two pi bond. Okay, if we were to connect them ataupun to form a bond with another atom, okay, tengok your Lewis structure. So this carbon, the first carbon, so this is C1, C2, right? So C1 has one hydrogen attached to it. Okay, so this is hydrogen will be coming in order to form sigma bond. Same goes to C2. C2 pun ada one hydrogen. So the hydrogen will overlap with the hybrid orbital from SP. Bukan dekat unhybridized P. Unhybridized P ni untuk cuba you tengok pi bond tu dekat mana. That atom will be involved in the pi bond formation. Okay, alright. So this would be sigma. How about this one? Satu lagi unpaired electron ni, nak pair dengan siapa? Remember, we have between the two central, okay, we should have one sigma bond between them. Okay, alright. So this one between C1 and C2, this is the sigma. Yang kat tengah ni lah kalau kita nak tunjuk. Mana-mana pun boleh tapi kita represent, saya nak pilih dekat tengah. So this will be sigma. Okay, ni yang sigma tadi between the hydrogen. Okay, we have two pi bond, right? Kita ada dua pi bond dekat situ. Pi bond number 1, pi bond number 2. So how do we represent these two pi bond? So the first unhybridized p electron ni in the unhybridized p orbital, the electron in the unhybridized p orbital will overlap with one another, C1 and C2. This is the first pi bond. The second pi bond is from the second unhybridized p orbital. Okay, the electron from the unhybridized p orbital. Second pi bond. Okay. All right. So how do we draw the what do we call that? The orbital overlap for C2H2. All right. So padam, clearkan everything. Okay, what you need is your, what do we call this? Your Lewis structure. Okay, all right. Mana nak buat ni? Okay, so let's start from the hybrid orbital itself, the central itself. So this is C1 is SP kan? C2 is also SP. Okay, all right. So we should draw two loops. Okay, all right. So this is for C1. Loop. And this is for C2. Okay, make sure that you label everything C1. Then we have C2sp. Okay, alright. So kita dah cover for carbon, guys. Alright, so next, let's move on to the hydrogen. Okay, so let's draw hydrogen. Let's use black. Okay, this is hydrogen. So that. Okay, so nak tunjukkan the bond. How about the bond, guys? Okay, let's use green color. So this is the bond, kan? To represent the bond, we represent the electron. Okay, 1, 2. So one should come from carbon, the other one should come from hydrogen. Okay, don't forget to label, guys. 1. Okay, saya malas nak tukar color, saya pakailah color yang sama. Kalau awak nak buat cantik lagi, tukarlah color. Okay. Alright. Yep. Okay, so we have this one already. Kita dah ada in our orbital overlap. Okay, let's go for the sigma bond first dekat between the two carbons. So this one right here yang di overlap ni, this would be the sigma. So kita dah settle for one of them from these three bonds. Okay, so that would be sigma. Alright, so how about the rest? These two bonds. So how do we represent that? Okay, let's have purple. Okay, so that means we should have C1 should have, this is one unhybridized P. This is only one unhybridized P. Since we have two, that means we have to draw two. Saya pakai color lain ya. Biru. Another one, saya buat kat sini. Ya, alamak buruk. Okay. Alright, so sama juga for C2, we should have two of them. So this is one set. And purple, another one set. Okay, this is the unhybridized p orbital. Don't forget the electron. Let's do for the purple first. Okay, these two will overlap, guys. Purple lah, right? This one. That will be the first pi bond label. Okay, the first pi bond. Secondly, change color to maybe we can have orange. Okay, so we have one electron in the blue colored unhybridized P. Okay, these two will overlap atas dan bawah ya, serentak begitu. Ya, that will be the second pi bond. Okay, second pi bond. Dah siap for your orbital overlap. If you were asked to label the bond form, okay, is it the sigma or pi bond, make sure you label lah. So this is sigma, sigma, this is also sigma, and then what else? Okay, that's all for sigma. And then how about pi? So we have labeled that already. Okay, we have that dekat sini lah. Okay, done for the orbital overlap. Yep. Okay, and then we have an example. Okay, right. So in the example, you have to show the hybridization of carbon, and nitrogen atom in HCN by using orbital diagram. So we have two questions here in terms of orbital diagram and also orbital overlap. Okay, and then you have to label the formation of sigma and pi bond for both questions. Okay, so far I have mentioned to you that normally central will be the one to form hybrid. Okay, to undergoes hybridization. Central will be the one that form hybridization. But okay, I do highlighted this in in our last week lecture. If the central is doubly bonded or triply bonded with the terminal atom, okay, the terminal atom will also form hybrid. Okay, so please take note on that. Please make sure that you have that information in your notes. Again, saya repeat, okay, if the central, which in this case carbon, form a triple bond ataupun a double bond with the terminal atom, which in this case nitrogen. Nitrogen is the terminal atom. Okay, this terminal atom will also form hybridization. Okay, it will also hybridize. Okay, all right. So how do we determine the type of hybridization for the central and also for the nitrogen? Sama, basically the same as what we have determined earlier. Okay, we are going to identify the number of electron group on the central and also the number of electron group on the nitrogen. Okay, basically we are just going to count the number of electron group. For carbon, we have 1 and 2. That means it is sp for carbon. Okay, and as for nitrogen, 1, 2. Make sure that those electron group, okay, they are directly attached to the atom that we are interested in. Okay, which in this case, it is also sp. Alright, so now, kita dah determine kan, this should be determined earlier, okay? So this will carry 1 mark. This is either half or each one of them is 1 mark. 1 plus 1 is equal to 2. Okay, simple saja. So please do not get it wrong. Unless you punya Lewis structure salah, then it will affect your, of course it will affect your type of hybridization. Okay, so again, Lewis structure is very, very important. Okay, so let's start with orbital diagram first. Okay, orbital diagram. So as you can see, you kena ada dua, carbon and nitrogen. Same goes to just now, carbon and carbon tadi. The reason dia tak tunjuk is because dia form hybridization yang sama, the same hybridization. Tapi by right, dia kena ada side by side. C1 and C2. Okay, macam ni, exactly the same as this. The reason dia tunjuk for this one is because one is for carbon, the other one is for nitrogen. So from the ground state is already different. Tapi sebenarnya dia sama ke tak sama ke, dia kena tunjuk dua orbital diagram dekat situ. Depending on the number of central lah. If we have 5, that means you have 5 orbital diagrams kat situ. Okay. Alright, so this is carbon. So we have determined that earlier just now. This is sp and sp, right? Okay, so make sure that for carbon, okay, it still will undergoes excitation. Kenapa? Because as you can see from the carbon, you ada nampak lone pair on carbon tak? So there's no lone pair on carbon. Kalau you tak excite this one to into the p orbital, it will end up having the full fill. The carbon will end up having a full fill orbital. So remember, a full fill orbital represent the lone pair. So when you refer to the Lewis structure, carbon does not have lone pair. So by right dia tak ada full fill orbital. Okay, alright. So this is used to one of the electron from the s orbital will be excited into the p orbital. So we have S and P having all unpaired electron. But remember, okay, berhati-hati. What we want is only sp. Kita tak nak ambil semua sp3 ni. That is why it is very important for you to determine the type of hybridization. Because nanti akan shock sendiri, okay, dia akan ambil semua ni. Dah lompat, ambil semua. Jadi sp3. Okay, macam mana nak form sp3 sedangkan dia adalah sp? Alright, so that's why this is our reference, sp. So that will be our reference. So dia lompat, excite, and it will only combine these two. Okay, dia hanya ada dua saja dekat situ. The rest, these two will be left unhybridized. Okay, because these two will later on form pi bond. Okay, alright. So on the carbon we have pi bond, 2 pi bond, 2 sigma bond. One is between hydrogen and carbon. The second sigma bond is between carbon and nitrogen. So this pi bond explains this unhybridized p orbital. Okay, no wonder lah dia ada dua unhybridized p orbital because it has the carbon has two pi bond in the Lewis structure. Okay, alright. So saya dah serabut dah tu. Okay, kita pakai balik. Alright, how about nitrogen, guys? So this is nitrogen, the ground state of nitrogen. So we have determined that earlier it should be sp, kan? Alright, so for nitrogen, it's not going to undergo excitation. The electron will not undergo excitation. Okay, so this electron will remain as is. Dia takkan lompat. Dia tak boleh masuk D. Okay, dia tak boleh masuk D. Kenapa? Because nitrogen must follow octet rule. It will not expand. Okay, because it come from n is equal to 2, period 2. So we do n is equal to 2, there's no d orbital. Okay, alright. So as you can see, and then one more thing, we have one lone pair there. So bear in mind, for the hybrid orbital later on, you should have this full field orbital. Okay, alright. So ground state, this is ground state of nitrogen. Excited state of nitrogen, as you can see, they are the same. Okay, they are the same. All right, for the hybrid, only one s orbital and then one p orbital will be hybridized. S memang ada satu lah. Okay, s orbital and one p orbital will be hybridized and form this bond. Okay, all right. And then the two orbital yang tertinggal tadi will later form apa nama tu? Pi bond. Okay, all right. So, kalau nak tunjuklah dekat atas ni. Jom kita tunjuk atas ni. Okay, show the formation of the bond. Alright, so refer your Lewis structure. Okay, so H. Kita represent the H, the pi bond. Okay, pi bond. Okay, dia akan form dekat situ. So, that would be the hydrogen will combine with the electron from sp orbital from carbon and form a sigma bond. Settle for this one. Sigma dah settle. Okay, and then how about this one? Ni dengan siapa ni? Ini akan form dengan nitrogen. Okay. Sigma. This one, the middle one. How about these two? They akan form the first pi bond. The second one, the second pi bond. Done. Settle. How about nitrogen? Settle kan? Okay, this one lone pair kan? This is lone pair. So we have it on the Lewis structure there. Like I said, they should be aligned. Your Lewis structure, your orbital diagram, and also orbital overlap, okay, they are all need to be aligned with one another, right? Okay, so ni baru dia nak address lah soalan tu. You can see it's actually the same. Okay, it's the same as what I've shown to you just now. Okay, it's actually the same. It's just that yang ni dia buat lain sikit. SP dekat bawah, 2P dekat atas dia. Nampak tak? Okay, dia tunjuk formation of SP. This is carbon. Okay, this is nitrogen. So this between carbon and nitrogen, a single bond will be formed, a sigma bond, and this one from hydrogen. See? Okay. And then this would form the first pi bond and second pi bond. Okay, you may be wondering, madam, nak go for this one, how do you draw? Should we go for this one, this form of orbital diagram ataupun this form of orbital diagram? The previous one. Yang ni yang saya tunjuk ni. Okay? Alright, you can choose any of these two lah. Mana-mana pun tak apa. Both also correct. But to me, personally, I would go for this one. So, orbital diagram yang kita memang dah pakai for all the hybridization, we have been using this type of orbital diagram. So, let's just stick with this one. Saya lah, to me, personally. Okay, I would go for this type of orbital diagram. Apa yang you kena buat adalah buat draw macam ni lah, hydrogen, and then connect these two between carbon and nitrogen, and then the pi bond. Dah siap. It's the same, guys. Benda yang sama. Benda yang sama. Okay, the reason dia dekat bawah sebab P before dia hybridize, the energy is higher than the SP. SP is the hybridized version of orbital, betul tak? Bila dia hybridize, the energy dia, the energy of hybridized orbital is lowered ataupun is reduced. That's why the energy dekat sini dia berbeza. P has higher energy than SP, hybrid orbital. That's why dia buat P ni dekat atas, hybrid ni bawah sikit. Okay, so apa nama tu, tak kisah, doesn't matter if you decide to go for this one pun betul, if you decide to go for the most common one just now pun betul. Okay, right. This is the lone pair. Right, this is in terms of orbital diagram. Yeah, this is in terms of orbital overlap, guys. Orbital overlap. Okay, so basically the same as just now tadi kita ada C triple bond C H H, right? So samalah kita draw for this one. As you can see, kita ada dua set of unhybridized P. The what do we call as the purple and also the yellow one for carbon and nitrogen. So we have 2 pi bond there. Okay. Don't forget the electron, okay guys? Don't forget the electron, the arrows. Without the electron, that means your mark will be deducted. Okay? And then moving on, baru dia introduce the SP3D. Okay, they introduce the original slide, introduce the SP3D. Okay, if it's all single bond, then this is how it looks like. If there is one lone, if there are lone pairs on SP3D, example, if we have 2 lone pair, so this is how it looks like. Okay, all right. And then we have SP3D2. Baru dia tunjuk SP3D2. If it's single bond, all single bond, so this is the hybrid orbital form. Okay, for the central. And then if we have lone pair, still SP3D2, that means we have one full-filled orbital. In this case, we have only one lone pair, that means we only have one full-filled orbital. Okay, that represents the lone pair. Alright, so itulah sequence of our original slides. Basically, the slides are the same. It's just that the arrangement are different. But my approach was to introduce to you in terms of category. Okay, kita ada bonding, and then we have lone pair, and then lastly we have multiple bond. Okay, all right. So we have discussed this example before, show the hybridization of the central atom in the molecule below by using orbital diagram, determine its molecular geometry and bond angle. Okay, all right. So the in terms of orbital diagram, okay, this is previously Vesper, okay, because the question is asking also for molecular geometry and bond angle. The one that we learn in this subtopic is hybridization. You have to show in terms of orbital diagram, not orbital overlapping. But again, for your practice, okay, try buat both orbital diagram and also orbital overlapping. Okay? Right. So that is ASCL3 trigonal pyramidal and ASCL5, which is trigonal bipyramidal. Okay? Right, determine dulu dia punya type of hybridization. It is sp3. 1, 2, 3, 4. It is sp3. And as you notice, we have one lone pair there kan. So you dah boleh expect dah. Okay, masa hybridization, you should have one full-filled orbital there. Right? Okay. Okay, checkpoint 19. Question 1. Show the hybridization of the oxygen atom in water molecule using orbital overlap. Using orbital overlap. Okay. All right. So, H2O. Okay. All right. So, the Lewis structure for H2O will be this. Sebab saya dah tahu. Kalau those yang tak tahu, meaning that you have to go through the process. Kira all the valence electron and whatnot so that you can come up with this Lewis structure. Okay. For the hybridization, we need to know the number of electron group on oxygen. Okay. Alright, on the central. So we have 1, 2, 3, 4. It is 4 electron group. That means it should be sp3, guys. Okay, bila you dah tahu sp3, dia nak orbital overlap, betul tak? The question wants the orbital overlap. That means you can prepare 1, 2, 3, 4 in tetrahedral shape. Kalau the real molecular geometry for H2O be bend lah, because originally it is tetrahedral. The electron geometry is tetrahedral. So how do you draw tetrahedral? Macam ni. Yeah, this is tetrahedral kan. So you have one lone pair there and then another lone pair here, katakanlah. This is two lone pairs. So hydrogen, hydrogen. Okay, so the molecular geometry is band shape. Pada band ataupun V shape. Okay, but we are focusing on the hybridization kan. So we just need to know that it is sp3 and we have 4 loops there. Okay, alright, so next, hydrogen. So we represent hydrogen here. Okay, so this is hydrogen, so done. We have the oxygen just now, so make sure oxygen, label oxygen, and it is sp3. Okay, alright, so electrons, so the bonding and the lone pair. So to represent the electrons, so this bond, okay, you should have the electrons in the overlap region. Okay, there you go for the bonding. And then these two lone pair, how do you represent this? Dekat situ. Yep, dah settle for H2O for the orbital overlap. Okay, again for your practice, try to prepare the orbital diagram for H2O. Okay, just for your practice. Okay, question 2. Show the hybridization in ethanol using orbital overlap. Again, dia nak minta orbital overlap. Label the hybrid orbital for each carbon atom. And then you have to label the sigma and pi bond. Alright, okay guys. As you can see, we have 2 central, 1, 2, C1 and C2. And this second central form double bond with the oxygen. Okay, of course, these 2 central will have its own hybridization. Okay, but since this second carbon form double bond with the oxygen, which in this case, oxygen is the terminal atom. Tapi since they form double bond, the oxygen also will undergo hybridization. So ada 3 hybridization lah yang you akan come up with. Okay, alright guys. How about C1? What is the hybridization for C1?
sp3.
Sorry guys, I
sp3.
got distracted by a message that is okay. Okay, again.
sp3.
sp3. Okay, is it correct, guys? How about others?
Yes.
Yes.
Okay. How about C2?
sp2.
sp2. Okay. Betul ke? The rest agreed?
Yes.
Agree.
Alright.
Yes.
How about oxygen, guys?
sp2.
sp2. Agreed? Ada yang tak agree? Ada yang nak bangkang? Saya bangkang. Kenapa bangkang? Saja-saja. Okay. Okay, alright, good, very good. sp3, sp2, sp2, bagus, betul. Okay, in case somehow ada among of you yang tak nampak lagi, okay, kita kena count the number of electron group that are directly attached to that particular central. Okay, alright. So focus on this central. Dia jadi bulky macam mana pun lantak P dia kat situ, lantak P. Focus on the central itself and then focus on the electron group that are directly attached to it. Okay, dia jadi kat sini nanti dia bercantum lah dengan apa benda, carbon, another sulfur ke apa. Biar dia situ. Don't get distracted by that. Okay, alright. So this C1 is only attached to these 4 groups. That means it should be sp3. Okay, see the second carbon, it is attached to 1, 2, 3. sp2. How about oxygen? It is attached to this one set, 1 kan? 2, 3. 3, sp2. Okay, as simple as that. Alright. Label hybrid orbital for each carbon atom. Okay, let's draw, guys. Draw je pun. Orbital overlap kan senang. As long as you have the what do we call that? The orbital overlap. As long as you have the Lewis structure. Okay, we have determined this just now. sp3, sp2, sp2. Okay, alright. So let's start with this carbon first. Okay, dia adalah sp3 kan? Okay, saya draw dekat sini. Okay, ke atas dia ni. So it should have 4 loops lah. Okay, 1, 2, 3, 4. Okay, baring kan ni. This is tetrahedral shape. Tapi dia baring. Okay, because saya ingat situ itu. And then this will be carbon. sp3 guys, carbon sp3. Okay, alright. Next, sp2, 1, 2, 3. sp2 ada 3 loops sahaja. So we are done with C1, C2 done. And then how about oxygen? It is also sp2 kan? Tersengit sikit lah, sorry saya terbuat kat bawah ni. Tak apa, dia tak ada, asalkan you form bond dengan orbital yang betul. Okay. 1, alamak besar pula. 2, gila. 3. Ish, buruknya. Okay, alright. So, done for oxygen. Okay, now label oxygen is sp2. Carbon, second carbon is sp. Okay, alright. Next, okay, kita go for terminal atoms. Okay, hydrogen. Okay, so this is hydrogen kan? So we have 3 of them. Hydrogen, hydrogen, hydrogen. Settle, settle, settle. And then we have hydrogen, 1 hydrogen on the carbon, the second carbon. Yes, we do have that. Okay, now label. Okay, alright. So tick. Okay, don't forget the electron, guys. The electron in the overlap region would represent the bond. Yep. Tick, tick, tick. And then between the carbon, guys. Okay, this one also settled just now. Hydrogen tadi kan? Okay, between the carbon here. Yep, this one. Okay, done. This is sigma. Okay, guys, this is sigma. All right, how about carbon and oxygen? Okay, we have sigma bond here, 1 sigma bond. So, which is here. Okay, tick juga, settle. And, yeah, settle lah. Okay, all right. So, kita ada, don't forget guys, we have lone pair and also this one. Kita belum tick lagi, the pi bond kat situ. Green. Okay, ini tak boleh biar kosong ni, mesti ada benda dekat dalam. Okay, as you can see on the oxygen, we have 2 lone pairs there. Okay, alright. Okay, lone pairs done. Next, how about the pi bond? The last but not least. Okay, so we have pi bond kan on carbon and also hydrogen. So please remember that the pi bond kita boleh represent it using the unhybridized P. Okay, alright. So we have 1 on carbon. We have 2, on oxygen. Alright, so don't forget the electron and draw a line to connect these two, atas dan bawah. So this would be your pi bond, one pi bond. Finally, semua kita dah buat. Kita represent it well using the orbital diagram. Senang kan? Tak payah pakai using the orbital overlap. So we don't need the orbital diagram as much, okay, because we can use the Dewey structure for our reference. Okay? Right. So dia suruh show the sigma and pi bond. So show lah. So this is sigma, sigma, sigma. This is also sigma. Where else? Alright. This is sigma and then pi. Okay, pi. Dah tunjuk dah pi. Dan. Okay, settle. So this is the answer. Yes.
Can you show the orbital diagram for oxygen atom? I want
Orbital
to check
diagram for the oxygen atom.
I want to check mine.
This one. Orbital diagram is SP kan? SP2. Okay. Initially, saya tunjuk untuk oksigen je lah ya. Yang lain tu awak boleh buat sendirilah. Okay, oksigen ground state dia 2S and 2P, group 16, right? And then excited state, this is ground state. Oxygen excited state. So it should be SP. SP2 kan? Dia nak SP. Nampak tak? Madam dia dah distracted dekat situ. Okay, nak buat apa ni? Perlu ke dia lompat? No, tak perlu. Okay? Alright. Dia tak perlu lompat sebab dia tak boleh lompat. Dia tak ada D. Dia tak ada 2D dekat situ. Tak ada 2D is not exist. Okay? Alright. So basically samalah. Kita draw dia exactly the same. 2S and 2P. Hybrid part. Nak apa tadi? Nak SP2 kan? That means you hanya ambil this one saja guys. Only take this one saja. Jangan asyik-asyik nak ambil semua. Asyik-asyik nak ambil semua jangan. Ambil, you dah decide SP2 just now. Tada! Okay, so these two explain the lone pair present on oxygen. This one will form bond with carbon, second carbon, okay, in the molecule. This one will form pi bond. This is the apa nama tu, the unhybridized P. Dia ambil 3 je kan. So this is the unhybridized P. Make sure dia jauh dia, jangan dekat-dekat Make sure dia ada gap lah. Okay, so this one will form the pi bond. Pi bond. Okay, so this is for oxygen. Okay, maybe you can try for C1 and C2. Practice guys, practice. Dia tak minta pun practice. This is for your practice. Kalau you even though dia tak minta, you still do it. Okay, you dah banyak sangat practice. And then later you can have your, what do you call that, pass years. Okay, sebab dia tak minta pun you buat juga. So that is also your practice. Ini apa nama, duk cari-cari soalan dekat cari nak apa nama tu, yelah mungkin tutorial tak cukup ke apa kan. So tengok checkpoint, tengok tutorial question pun, you be extra maksudnya dia tak minta you jawab, because after all dia adalah tutorial, dia adalah checkpoint, those are for your practice, okay, your exercises untuk you get better for exam. Tapi during exam jangan pergi buat, dia tak minta you pergi buat, jangan. We don't have time for that. Focus. What the question want, kita bagi exactly what the question wants. Because we have a lot of question, we have time limitation there. Kita tak ada masa kita nak ada extra time so that we could check again. Sebab kita selalunya kita akan guna exactly time yang ada tu buat sampai ke titisan nyawa terakhir. Peluh terakhir masih menjawab soalan. Memang tak sempat check. So that is not a good practice lah. So good practice should be you ada extra time for you to recheck. Okay, so that's why kita advise student to jawab apa yang soalan nak for your exam. Untuk tutorial checkpoint tak apa, be extra. Dia tak minta you jawab. Saya akan checkkan untuk awak. Saya akan komen. Kalau ada, kalau you tak bagi, then macam mana saya nak check kan? Okay, saya ni examiner ni. Awak kena guna saya ni sehabis baik untuk nak tolong awak. Saya cakap real time ni, exam tu macam mana saya check, saya tick, saya wonder dia ni betul ke tak betul. Saya apa yang dalam otak saya beritahu awak, saya share. So kalau awak tak gunakan saya ni sehabis baik, rugilah. Okay? Saja sharing. Tiba-tiba. Madam biasa je. Okay. Alright. So this is for H2O. Saya dah check dah. Kita dah buat sama-sama. Just sama-sama ke? Okay. Kita buat tadi. H2O. And then this is for the hybridization. Nampak tak? Just now kita dah buat dah this one. Okay. Alright. Alright. Okay. State the type of hybridization of each carbon atom in the following molecules, guys. Label the sigma and pi bond. Maybe we can call up names. I can call up names, okay, so that you can read out your answer. Okay, jom. Siapa? Irfan, Muhammad Irfan Hanis. Irfan?
Yes, madam.
Alright, Irfan. Okay, can you please state the type of hybridization for all the central in A? Okay, let me just label first. Okay, so let's start with C1. What is the type of hybridization for C1?
SP2.
SP?
2.
2. Okay, how about C2?
SP2.
SP2 as well. How about C3?
SP3.
SP3. Okay, guys. Are you guys agree with Irfan's answer?
Agree.
Agree.
Yes.
Very good.
Yes.
Okay, betul. Okay, so saya pun memutuskan dia adalah betul. Okay, senang kan? Tengok je boleh tahu kan? So tolonglah jangan salah, rugi sangat salah. Okay, alright, B. Let's have, aduh, B ni rasa macam tak nak buat sebab senang sangat lah. Tak payah buat lah. Jom lah, tak payah. Jom. Dan label kan, you have to label the sigma and pi bond. Okay, so all the single bonds would be sigma. Okay, the double bond, it would we would have sigma and pi bond. Okay, that's this one. Pi, sigma. So we only have one pi bond and one sigma bond. Okay, guys, please be careful. Okay, before you answer this type of question, you make sure that all the bonds are visible. All the bonds are visible. Okay, we do have one question last time in the objective question past year. Dia bagi macam ni, dia suruh determine the number of pi and sigma bond for in the molecule. Dia cakap alright, dia expand everything. It's just that ada satu tu, katakanlah kan, CH3, dia buat macam ini. And then the rest CH, macam biasalah. Okay, dia connect dengan C and so on lah. Okay, cuma satu tu je dia tak tunjuk bond. Okay, and then student end up, of course, dia akan miss out this bond dekat sini, satu bond dekat situ. Sebab apa? Sebab soalan tak tunjuk. Perlu ke soalan tunjuk? Not necessarily. Okay, you kena tahu that the carbon must have 4 bonds in order to achieve octet. So ini dia baru 3. Itulah semangat sangat nak kira kan, number tu kan. So please be careful. You kena apply the concept of octet tu. You kena make sure that okay, carbon, nitrogen, those atom mesti achieve octet. You kena, not only you have to count, you have to make sure of that. Okay, are they all octet? Ni expanded ke? Dia incomplete ke? Macam tu. Okay, so saya boleh kata 90% of the students were wrong at that time. Hanya beberapa je yang notice that carbon and hydrogen has another one, a single bond between these two. Okay, itu pasif in the objective question. Remember, your objective question for one question carries 2 mark. 2 markah tau, banyak tau. It's either 0 or 2. So it's very very important. Dia akan drag down, tarik you punya markah banyak. Sebab structured question, soalan yang you kena jawab tulis tu, dia banyak markah, but dia ada pecahan. Let's say dia kata 2 markah dekat situ. It can be 1 mark ataupun half mark, 1.5. Okay, dia ada pecahan dekat situ. But for objective, dia is either 0 or 2. 2 or 0. Kalau you salah, you tak ada talian hayat, you memang salah lah. Tersalah. Tak ada. It's either 0 or 2. Okay? Alright. So objektif penting ya, jangan main bantai. Memanglah you bantai, kalau you kena, you are considered lucky lah. If not, you are considered malang tak berbaru. Okay? Please be careful for your objective. Right, any question related to hybridization before we proceed to the next subtopic? So this would be the last subtopic lah. Bukan subtopic, this would be the penutup. Okay, penutup for hybridization, and then we are going to the next subtopic, which is the intermolecular forces. Ada anything related to hybridization just now?
No.
Tadi so far so good Alright, so let's move on to the application. Okay guys, hybridization of carbon allotropes. Okay, again, why carbon? Of all the atoms, element in the world, in the earth, why carbon? Because carbon is one of the most abundant, in fact the most abundant element in the world. Okay, that's why kita more interested on carbon lah, because carbon has so many application. Okay, so one of it can be used as banyak lah, tak payah cerita lah, memang banyak lah. Okay, carbon, and then it's it can be very very cheap and it can be very very expensive. Okay, alright, so allotropes of carbon. Allotrope is like the structural form. Okay, it can have different structural form. The carbon, even though it is carbon, but it can have different structural form. Itu maksud allotrope. Okay, source dia sama, carbon, but they can have different arrangement. So that is what it meant by allotrope. So the most common one would be graphite and diamond. Okay, graphite, the hybridization is sp2, but for diamond it is sp3. Okay, we have learned this earlier. Okay, carbon can form several hybridization. It can be sp, sp2, sp3. Okay, so graphite is sp2, diamond is sp3. So for graphite, this is the arrangement. Okay, dia trigonal planar sebenarnya. sp2 maksudnya dia adalah, imagine carbon, dia begini kan, sp2. Okay, H. Tapi ni macam tak cukup, dia macam, sorry, dia bukan H, sorry so dia tak cukup ada 3 ni. That means dia kena ada double bond dekat situ. Sebab carbon must be octet. So in order to form octet, one carbon need to form double bond. For sp2 lah. Okay, in order to form sp2, the only way is to have double bond. Kalau single bond, dia tak octet, tak boleh. Okay, alright, so it should be one double bond between the carbon. Okay, so this is how sp2, this is graphite, how graphite looks like, and then we have diamond. So diamond is in sp3. Okay, as you can see, this is, okay, assume this is the carbon, so it is attached to this 3 carbon guys. Kan nampak tak trigonal planar sheet? So dia layers by layers guys. Okay, it is layer by layer. But on the other hand, diamond, they are arranged in dalam bentuk tetrahedral kan. So this is how the diamonds are, the sp3 carbon are arranged in diamond. As you can see, dia akan form satu structure yang very solid. Okay, the network are very strong. Okay, so that's why diamonds are very, very, very strong. Okay, it is used to, one of the common usage of diamond is to cut metals. Sebab apa? Kekuatan dia tu, kestrongan dia tu. Okay, untuk digunakan sebagai pemotong metal ataupun other materials that are hard enough. So we may use diamond. So the one that you nampak ni adalah dalam bentuk jewelry, dalam bentuk barang kemas macam tu kan. Tapi you tahu tak diamond yang dia guna untuk construction tu, untuk potong-potong metal ke, untuk drill ke apa tu, dia punya tips dia tu, those are diamond. Jangan ingat diamond tu yang cantik-cantik, yang pakai kat rantai, cincin benda tu. Diamond tu digunakan dalam construction, tu tu potong kita punya lantai punya tiles apa apa panggil tiles tiles
Mosaic.
mosaic. Okay, mosaic ke ada lagi satu term. Yalah tiles lah ataupun mosaic. Okay, we use diamond tips dekat situ. So and then the common one will be jewelry lah. So it's very expensive, okay, because of dia punya rare structure dia tu. Okay, and then we have fullerene. So fullerene is quite recent. It was discovered in 1996. Okay, so firstly it was discovered as buckyball. Okay, so the scientists who discovered this, which was on 1996, okay, win the Nobel Prize. Okay, was a Nobel Prize winner lah. Atau nama dia fullerene okay, the what do we call this, dia punya discovery of this compound, okay, this allotrope is named after his scientist. So dia punya scientist dia nama dia Fullerene. Ada nama panjang lagi lah tapi nama dia Fullerene. Okay, so dia dapat privilege to name the material ataupun the allotrope after his name. Okay, and then 2010 which was very recent, okay, sebab currently kita 2021, dia 2010. Kita ada discovery of carbon nanotube. So this is how your buckyball looks like. It's like a cage dekat situ. Okay, dia macam cage dekat situ. So this cage ada banyak sangat kegunaan. One of the usage is to use this as a trap. Okay, ni carbon ni, yang kelabu-kelabu ni, kelabu ke biru ke ni carbon. Those are all carbon. So it can be used as a trap. Okay, let's say we can place a drug ataupun active ataupun compound in this cage, in this fullerene, okay, so that it carries this drug, for example, drugs to the targeted area and release the drug so that it can attack ataupun directly attack the, for example, cancer, okay, to treat the cancer. The problem with drugs adalah dia ada effect on the normal cell. The normal cell will be disturbed ataupun will be terganggu lah. Dia akan rosak lah. Okay, the normal cell will also be disturbed by having the drug in the body. So kita tak nak that to happen. So that's why dia ada banyak side effect kalau drug ni. So one of the technology is to trap the drug. Okay, and then this trap will carry ataupun this cage will carry the drug to the targeted area, for example dekat cancer punya tempat, and then release the drug pada cancer tu. Okay, pada cancer tu, and then it will do his job lah dekat situ. Its job dekat dekat cancer tu. So kuranglah side effect on the normal cell. Okay, so this is, if we extend further, it will form a bucky tube. Alright, so Buckminster Fullerene. I believe this is the name of the scientist, okay? And it also, Fullerene represent the C60, okay? C60 ataupun kita panggil dia buckyball lah. It consists of 20 hexagonal and 12 pentagonal ring as the basis of an icosahedral symmetry closed cage structure like soccer ball appearance. So each carbon atom is bonded to 3 others and is sp2 hybridized. Okay, so they are all sp2 hybridized. So this is how your Fullerene C60. Okay, previously we can have C60, C70. Okay, right. So initially it was C60 lah. Okay. All right, properties for allotropes. Okay, properties and application of fullerene, guys. Only for fullerene. Okay. Properties, it is extremely small diameter of nanoparticles. Okay, this is the technology, the current technology now. The size is nano. Okay, nano is 10 to the power of -9. It's very, very small. It helps in terms of absorption. Okay, it is very, very, very useful in the nanomedicine industry. Okay, like I said just now, we can use it as a cage to hold drug molecules. And then it has strong and high tensile strength. Okay, strong, high tensile strength. Sebab apa? How they are arranged in the structure. Okay, so they are very strong and the tensile strength is very high. So it can be used as composite materials. For example, macam materials that requires very, very strong ataupun high tensile strength like carbon fiber, tennis racket. Tennis racket kena strong lah. Kalau tak pukul dia dah patah kan, because of the impact of the game itself. Bila kita nak pukul dia tu, okay, it will be very strong impact. So kalau it's not strong enough, it will break lah. Okay, same goes to golf club. So those are considered as composite material. Dia adalah campuran tau. And then we have power. The properties is considered as powerful antioxidant and anti-radical. It can be used as cosmetic in also pharmaceutical products. Okay, it also have high surface area ataupun volume ratio. This is good for the production of catalyst. Okay, kenapa? Because dia kan kecil kan. Bila dia kecil, the surface area become larger. Okay, the surface area become larger. So this is very good in terms of electron transfer. Okay, in terms of basically to enhance the surface area. For that, the reaction can take place. More reaction can take place. Okay, so that is for catalysis. And then excellent conductor. Okay, it is also an excellent conductor due to the presence of double bond. Okay, double bond. You may remember the resonance structure. Okay, where the electron will be delocalized. The electron tu boleh transfer. Okay, this side mula duduk sini and then transfer to the other side. So there is a movement of electron. Bila dia ada double bond tu, the electron can be move around. Guys tu. Bila dia boleh move around, that means it can conduct electricity. Okay, excellent conductor. So it can be be used as semiconductor ataupun superconductor. Okay, so those are the application and those are the properties and application of fullerene. In case you were asked in the exam, okay, make sure that you know what to answer lah. Okay, all right, we are done with hybridization. Finally, next we have intermolecular forces. Almost at the end of the chapter, guys. Okay, right. So let's move on to intermolecular forces. So we have 2 learning objectives for this subtopic. Make sure that you covered all of this once you have completed the subtopics. Okay, right. So ni kira yang critical part kita dah cover, kita dah lega. So next will be intermolecular forces. Okay, types of forces. We have intramolecular forces and also intermolecular forces. Intra is also known as bonding forces. Okay, all right. So it is attractive forces that hold atom together in a molecule. These forces exist within each molecule. They influence the chemical properties of the substance. Example is covalent bond. Intra means the bond that form within the atom in the molecule. Okay, intramolecular maksudnya internally. So this one we have covered in the earlier slides in the previous lecture. Okay, we are not going to cover this in this subtopic. So this is just to highlight the type of forces that we have. We can have intramolecular and intermolecular. Okay, but our focus for this subtopic will be intermolecular forces, guys. It's not involved in the bonding. It actually the forces that felt between the molecules. Intra tadi dalam molecule. H2O for example. Okay, dalam molecule tu ada oxygen and hydrogen. So these two are attached. These two are attached with one covalent bond. So that is what we call intramolecular. Okay, intermolecular is between H2O molecule and another H2O molecule and another H2O molecule. So the attraction between these molecules is what we call intermolecular forces. So dia non-bonding. Ada bond terbentuk ke? Tak ada bond. Dia adalah forces yang kita rasa attraction. Okay, so that is what we call intermolecular forces. Between, it should be between the molecule. These forces as in between molecule. Yeah, between the molecules, they influence the physical properties of the substance. Physicals like melting point, boiling point, what else? Viscosity, surface tension, those are all physical properties. Okay, if we disturb these forces, what will happen to the properties of the molecule? Okay, and the van der Waals forces and hydrogen bonds. So intermolecular forces can be in the form of van der Waals or also hydrogen bond. Okay, we will look into this later. All right. Okay, contoh again, like I said, this is what we call intramolecular, dalam. Okay, and inter like international, intranet, internet. What are the difference between those two? Inter means antara molecule. Okay, intermolecular. So this is the attraction that we are going to discuss in this subtopic. Okay, in order to overcome this, you may need to heat up the substance up until 100 degrees Celsius. Then it will be broken. But if you want to disturb this bond, you want to break this bond, okay, this force, okay, you may need to increase the temperature even higher. Okay, it may 100 ataupun 1000 or even higher than that in order to break the intramolecular. Okay, so intramolecular forces are a result of large charges, the charge of proton and electron interacting at very close distance because they are close to one another. Okay, it's because of the nucleus and the electron punya attraction. So we know that nucleus is very positive, electron is very negative. So when they attract, okay, so dia akan form bond lah. Dia akan form bond, okay? Alright. Okay, so kalau intermolecular forces pula is due to the smaller, okay, the result of smaller charge interacting at greater distance. Maksudnya the distance can be far apart, okay, compared to bonding tadi. So dia akan be due to this is slightly negative, this is slightly positive. This interaction. So this is attractive force due to slightly positive, negative, they attract one another. So there is a force between them. So itulah what we call intermolecular forces. Due to this, it is weaker compared to the intramolecular forces. Okay? Alright. Okay, so we have few types of intermolecular forces. One is van der Waals. Okay, so van der Waals can be divided into two. We have London dispersion forces and also dipole forces. Last but not least, we have hydrogen bonding. So we are going to look into these three. Okay, previously dulu we used to have more than this, but macam biasa makin lama kita buang. Lala kita tinggal 3. Okay, if I'm not mistaken, last time we used to have more than 5 tau. More than 5 of intermolecular forces. Tapi kita buang, kita pilih yang the most significant. Okay, if you would like to go to know more, that means during your degree ke, kalau you ambil in chemistry ke, yang ataupun courses that is related, okay, you will learn further. Okay, atau yang nak tahu interested more, you are you go ahead and read more lah. Okay, ataupun you can search on the internet. Alright. So, okay guys, let's start with London dispersion forces. Okay, so far we have 3. So let's start with London dispersion forces. Okay, it's the weakest intermolecular forces, yang paling lemah. Okay, it's the weakest because it is formed due to temporary attractive forces. Temporary ni hanya sementara. So everything yang sementara is not strong, dia lemah. Okay, because it's due to the temporary attractive force that results when the electron in two adjacent means sebelah, next to, okay, in two adjacent atoms occupy position that makes the atom form temporary dipoles. Okay, that form temporary dipoles. So you have been introduced to dipoles previously in the polarity subtopic. Okay, dipoles, di stand for two, poles mean kutub. Okay, dia ada dua kutub. Dia ada kutub positif, kutub negatif. Okay, so normally in the polarity, kita belajar permanent dipoles. Permanent dipole. So in this subtopic, in London Dispersion Forces, kita ada temporary dipoles. Okay, maksudnya dipoles tu dia jadi sekejap. Lepas tu dia dah tak ada dipole. Dia dah tak ada dipole. So that is what we call temporary lah. Okay. So in non-polar molecule, there is no dipole force. Iyalah, because it is non-polar, because there's no dipole. Non-polar has no dipole. There's no kutub dekat non-polar. Okay, so by right, there is no dipole forces kat sini Alright, so this is only present for polar molecule, guys. Kenapa? Because dekat polar molecule dia ada positive and negative, partially positive, partially negative ends. So that is what we call dipole. So this dipole, bila dia ada dipole, then only it can have dipole forces. Tak ada dipole, that means macam mana nak ada dipole forces? Kalau dia non-polar, so there should be no dipole forces. Okay, alright. Does London dispersion forces exist between all substances ataupun compounds? Okay, so these London dispersion, they present in all substances regardless whether it is polar or non-polar. Okay, regardless whether it is polar or non-polar, they are still available for that compound. For all compound lah basically, okay? Alright, so in detail, London dispersion forces is the instantaneous, maksudnya dipole that form at that instant. Pada ketika itu dia jadi. Bila dia bertukar, then dia hilang. There's no dipole. Okay, alright. The instantaneous dipole of the neon atom induce an instantaneous dipole in adjacent atom, resulting in an attractive forces between them. Okay, so this is our example. So we have neon. Okay, alright, so neon atom and another neon atom. Okay, so what type of intermolecular forces present for this atom? Okay, alright, so it is called London dispersion force. Okay, example, in a neon atom, though the electrons are spherically distributed over time, at any instant, one side of the nucleus may possess a higher amount of electron than the other. Okay, the atom has a small instantaneous dipole. Okay, alright, so the reason dia ada instantaneous dipole is because of, okay, we know that electron, okay, in the atom, for example neon, okay, electron dia ni tak stay in one place, dia move around, okay, somehow at that instant, at any instant lah, for example, at any instant, one side of the nucleus may possess a higher amount of electron. Okay, dia boleh evenly distributed and dia boleh unevenly distributed. Bila dia unevenly distributed, which means dekat kawasan one side tu become more electron than the other side. So it means that this side will be slightly negative and this side will be slightly positive. Betul tak? Dia terwujud secara tak sengaja. Okay, that's why we call it temporary dipole. So this motion, bila wujudnya temporary dipoles ni, slightly negative, slightly positive, the motion of this electron in one atom will affect the motion of electron in another atom, another neon atom. Okay, so this causes the instantaneous dipole of the atom change together, maintaining a net attractive force. So bila wujudnya slightly positive charge here, it causes the neighboring neon to adjust their electron, okay, the electron in the atom to be slightly negative here. Okay, ni induce, maksudnya they influence the electron to be, kalau sini this is positive, here should be slightly negative. Okay, the attraction between this positive and negative end, this is what we call London dispersion forces, guys. Remember, this is intermolecular forces between the two atoms atau between the two molecules. Bukan dalaman, dia luaran, okay? Alright, so this is what we call London dispersion forces. So imagine kalau the electron dia move around lagi, dia bertukar, so dia hilang lah. Ni tiba-tiba dia bergerak kan to this side, ke atas ni ataupun dekat bawah. That means there's no positively ataupun negatively charge dekat situ. So dia berubah pula dekat tempat lain. So that is what we call instantaneous dipole ataupun temporary dipole. Okay, so the attraction between these two ends is what we call London dispersion forces, guys. Okay, so it depends on the electron movement, placement of the electron in the atom itself. So we know that electron dia taklah bergerak berpusing ke apa, kita tak, in fact we do not know the exact location of the electron kan, tapi kita tahu dia always on the move. Okay, dia selalu dia tidak berada di satu tempat. So sometimes dia berada banyak dekat this side and this side kurang, wujudlah slightly positive, slightly negative. That is what we call instantaneous dipole. It happened at that time only. Okay? Alright, faham? Anything related to London dispersion before we proceed to dipole forces, guys? Okay? So far okay ke?
Okay.
Alright.
Okay.
Lemah je dengar Okay. Alright, next we have dipole forces. Okay, the term dipole represent the dipole that we have for the polar molecule. Okay, so dipole forces are attractive forces between the positive end of one polar molecule and the negative end of another polar molecule. Okay, then please bear in mind that it only occurs between the polar molecules. Dia hanya ada dalam polar molecule. Non-polar maksudnya you dah determine, oh, this molecule is non-polar. So that means the molecule will not have dipole forces. It can only have London dispersion forces. Okay? Alright. So when polar molecule comes closer to one another, their partial charges act as a tiny electric field that orient and give rise to dipole attraction. The positive end will attract the negative end of another. Okay, alright. So this is, imagine HCl, guys. Imagine HCl. So we know that H is slightly positive, Cl is slightly negative. Okay, so kita ada arrow kan sebenarnya towards the negative, the most electronegative atom. So this is what we call permanent dipole. Dia memang due to electronegativity different. It's not based on electron just now. Dia memang hydrogen is more electropositive than chlorine. Chlorine is more electronegative than hydrogen. So that is what we call permanent dipole. Okay, alright. So this will cause the neighboring molecule to adjust itself. Dia pandai dia berpusing. Okay, this is slightly negative, so it will adjust itself so that it will be attracted to the negative end. So ini akan jadi positif lah. Okay, so this is what we call dipole forces. Okay, so imagine if you have more than two molecules, so this is how it is arranged. Okay, so positive ends will be attracted to the negative end. So this is what we call dipole, guys. Okay, this is dipole. So those attraction is what we call dipole. Okay, simple. Okay, so that's why it is very important for you to determine whether the molecule is polar or non-polar. Macam mana nak tahu polar warna polar? Kena go back to the previous slides. Okay? Alright. Sebab kalau you salah dekat polarity, that means you will salah dekat this intermolecular forces. Okay? Yeah, dipole forces again. Okay, in polar molecule, the molecule tend to align. Dia pandai dia pandai. I mean the molecule will align themselves so that they will be attracted to the correct ends. For example, so this is negative ends. This is by right the positive ends. So this second molecule ataupun incoming molecule yang came closer atau come closer to this molecule, it will align itself so that the positive end, okay, will be attracted to the negative ends. Okay? So this attraction guys is what we call dipole forces. Okay. Last but not least will be hydrogen bond, guys. Okay, last but not least will be hydrogen bond. So hydrogen, the term hydrogen bond, of course, it will involve hydrogen in the forces. Okay, all right. But not just simply because of other hydrogen, that means it will form hydrogen bond. Not because of that. Other rules that you have to know, okay, in order for the hydrogen bond to form. The reason it's called hydrogen bond, bukan hydrogen bond, the hydrogen forces, is because of this hydrogen bond is the strongest. Dia kuat, okay, compared to the other forces just now. So dia kuat almost macam jadi bond lah macam tu, but it's not bond lah, it's forces between the molecule. Okay, alright. So first point that we have here is it's the strongest compared to other intermolecular forces, compared to dipole. Okay, and then all polar compound, again this hydrogen bond can only present in polar molecules. But please take note that all polar compound has dipole forces. Itu kita tahu. As long as it's polar, it will have dipole forces. Okay, but not all polar compound has hydrogen bond. Okay, but not all polar compound has hydrogen bond. Okay, how do we determine whether it is a hydrogen bond ataupun it's not hydrogen bond? It's just simply dipole forces. Okay, how do we do that? Okay, dia ada dua syarat, like I said. We have two rules in order to identify whether it is hydrogen bond or non-hydrogen bond. Okay, all right. So the hydrogen bond, belum lagi. Okay, the hydrogen bond is a special dipole forces. Okay, dia punya konsep dia sama macam dipole forces just now. It's based on negative end dengan positive end. Okay, they based on that. It's just that positive end should come from hydrogen. Okay, the positive end should come from hydrogen. Dipole forces just now, the positive end can be from any other atom other than hydrogen. Boleh, as long as it is positive ends dengan negative ends. But for hydrogen, dia kena the positive end should come from the hydrogen. Okay, not only that. The hydrogen must be attracted, okay, to fluorine, oxygen, or nitrogen, or in short, we can call it as FON. Kenapa? Because these three atoms are very electronegative. These three atoms are the most electronegative atom in the periodic table. Of course, being the first will be fluorine, followed by oxygen and nitrogen. It is very electronegative dengan hydrogen yang kita tahu memang very positive. So by right, dia punya attraction will be stronger lah. Okay, alright. Ada dua syarat yang you kena make sure. Dia ada dua. Okay, dia tak explain in detail here, tapi saya explain. Okay, please take note guys. The first syarat will be you have to identify internally. This is internally. That means it is in the molecule. Within the molecule itself, it must consist of hydrogen, consists of hydrogen, that is directly bonded ataupun attached to F, O or N. Internally dalam molecule itself. Syarat pertama. Syarat kedua, sebab we are talking about intermolecular, maksudnya between the molecules. The hydrogen should be the same hydrogen yang kita cerita kat sini, the same hydrogen tu must also attached ataupun attracted to the to form to the FON atoms externally. Okay guys, externally. This is we are talking about externally, maksudnya luaran. Okay, alright. So these are the two syarat yang you kena take note in order to identify whether the bond is a hydrogen bond ataupun it's not a hydrogen bond. Don't just simply because of dia ada hydrogen, therefore this is hydrogen bond. No, it's not as simple as that. Okay? You kena identify dalam molecule itself, maksudnya covalent ke apa benda tu, intramolecularly the hydrogen should be bonded to FON. And then that same hydrogen, is attracted to another molecule having FO ataupun N. So that forces between two is what we call hydrogen bonding. Hydrogen bond. Okay, ataupun hydrogen bond forces. Okay, ni syarat dia, tapi saya rasa macam tak clear sangat lah dekat situ. Make sure that either fluorine, oxygen or nitrogen, FON directly bonded to hydrogen atom within the molecules. So this is the first syarat. Second syarat dia tak explain further dekat sini. Okay, alright. So as you can see, we have two example, ethanol dengan dimethyl ether. Okay, alright, the boiling point of these two are different. Okay, ethanol is 78, whereas dimethyl ether is very, very low, which is -22. Okay, so what's the reason behind this very different boiling point? Okay, one of the reason is because we are talking about boiling point, kan? The physical properties. Okay, it's because of the presence of hydrogen bonding for ethanol. So it's the strongest, kan? So more energy is needed to break the forces. Therefore, the temperature become higher, okay, compared to the one that does not have the hydrogen bond, which is dimethyl ether. Tak ada. That's why they're very low. Okay, all right. So this is what I meant just now. Okay, imagine, guys. We have HF. Okay, all right. So this is the first molecule. This is the second molecule. Betul tak? Okay. So syarat pertama, the hydrogen. Okay, focus on the hydrogen. Okay, so this is the hydrogen for the first molecule. This hydrogen is internally secara dalam molecule itself is directly bonded to FO dengan N. Betul tak? Syarat pertama. Okay, tick, dia follow. Syarat kedua, the same hydrogen must be attracted to FO ataupun N. Okay, secara externally. Alright, so this is another molecule, kan? H dengan F. So dia obey dua-dua syarat. So this force is what we call hydrogen bond, guys. Faham tak? Dua syarat tu dia kena obey. Okay, let's look at second example. Okay, alright. So focus on the hydrogen, look for the hydrogen. Okay, this is the hydrogen. The first syarat, hydrogen must be directly attached to either F ataupun O ataupun N. So yes, this hydrogen is directly attached to O. Okay, alright. Syarat pertama dah obey. Syarat kedua, so this hydrogen must be externally attracted to F ataupun O ataupun N. So we have oxygen here, right? So this attraction is what we call hydrogen bond. Okay, you may have another molecule. You boleh check. You kena follow those two syarat in order to have the hydrogen bond. Okay, our water molecule have hydrogen bond. Okay, sebab this is hydrogen, betul tak, yang directly attached to oxygen, and then it is also attracted to oxygen juga. So this is again, this hydrogen, this is what we call hydrogen bond. Okay, all right, so let's stop here. So we are going to continue tomorrow for the rest of the subtopic in topic 3, so that on Wednesday kita boleh start topic 4. Okay, guys, boleh mulakan hidup baru lah. Dah lama sangat dah kita on topic 3 ni. Alright, any questions so far? Okay, I think there's no question from the floor. Okay, so let's wrap up our session. Okay, thank you everyone for your attention and Assalamualaikum.
Thank you,
Bye-bye.
madam.
Thank you, madam.
Thank you.
Thank you, madam.
Thank you, madam.